Okay. Hey everyone, this is Eugene, and today we are with Patrick, Matt, and William, and we're gonna record another episode of live contract reviews. And today we actually have a request from Metapool. So there's a new contract, and it creates a new staking token. So let's actually dive in. I've started compiling it. So I compiled the contract and I'm doing testing right now to see if it actually works. And Metapool is a project by Narwallets, which is a MetaMask-like wallet. And the idea here, let's see what you can do. You can deposit, withdraw, buy. Okay, something didn't work in tests, which maybe it was wrong build or something. Maybe my my version of this isn't correct. So anyway, just test my capture. Okay. Anyway, it does compile, which is good. So tests are separate. So you can buy as near stake, then you can sell, which gives you immediate unstaking. So it's kind of wrapped staking token. So you can do unstake, wait, finish. I guess it's stake, wait, unstake, wait, finish, withdraw. That allows you probably to unstake. So you can also stake, which gives you a token. You can provide liquidity, remove liquidity, retrieve unstaked, and distribute staking and staking. Okay. All right. So majority of work, it looks like is done. So let's jump into the source of lib and see what it is. So it has some constants. You can get contact info. That's cool. Oh, by the way, it uses nearest decay tag 240, which is fairly old. And even so, it's called 240. It's still probably older than this one. Maybe that was just a patch, so it may be not as old, but somewhat in the middle. Soon we're gonna publish 3.0 that has a bunch of cool stuff and a lot of helpers, so that would be nice. Okay, so it's split into multiple modules. There's an allocator, internal account, I don't know what it is, debug. Oh, that's actually a method that we introduced. It's a log macro. So this is external API to staking pool, and it implements a staking pool. This is kind of interesting. What is this? Okay, just to make it clear that this is a string. So staking pool is a core contract that is defined in core contracts, and the APIs are known. And this is a standard APIs. There's also a separate API that you probably want to use, which is get account, that returns you a composed value of 3 of this, essentially. Now, meta staking pool owner callback. So this is us, I assume. So this is this contract, and it implements this bunch of callbacks. Index amount, stake maybe deposit, unstake, unstake all, on get result from transfer poll result. I actually not sure what it is for, but it looks like it's some legacy logic around when the transfers are enabled. Total balance. So this is our core contract, and it does implement default for some reason. Oh, it's a pull info. It's not core contract. Okay, so it has some data. Let's scroll down to the main contract. So main contract called metapool. It has owner ID, mean account balance, some metadata, total available. Not clear in what balance is total available. Is it near a token? Total for staking, total actually staked, total stake shares. Okay, total meta. Okay, so that was near, and this is more data. So this is what I started to see, like more complicated contracts, they get way more fields in the main structure, which means every time you do any operation on the contract, you have to deserialize all of this and later serialize all of this back. So this is cost you gas and storage cost for writing it and reading it. And for fungible token metadata, we introduced a new collection that calls lazy option. And this is what I talked in the last review about the berry cards, where we had trade data that doesn't need to be deserialized every time unless you actually want to trade. So it might be helpful to split our main structure into these lazy option fields and implement them separately so they don't need to be deserialized unless you actually operate on it. And yeah, we can talk about lazy option later in the next video once we actually publish it. So there are some fields. So there's an ordered map on accounts. The string here, I would prefer to use account ID. And the reason for this is it makes it a little clearer that this is an account and not an actual.
Could you also use a valid account ID type?
Yeah, you can use a valid account ID as well if it supports BORSH. So let's see if it does. Yeah, it does support BORSH, so it should be fine. Also, I started to look into how to decrease trust size, and there is huge amount of logic coming from strings, because let's say if you go into string, then you have methods such as from UTF-8. So from UTF-8 method takes a vector and tries to parse this vector. So we actually spend extra data every time we parse an account ID as a valid UTF-8. In theory, account cannot even have an escape character inside, so it will be immediately non-valid. So what we may want to do is to have an account ID represented as a vector of U8 internally and not as a string. But then you can implement a display for the account ID and conversion to string if you want and stuff like this. But that will give us some performance boost every time we deserialize a string. We don't need to call from UTF-8 on the string. Staking pools as a vector, so you cannot really have that many staking pools, which is probably what we want. It's a list of pools you want to diversify in. So it's not in an order, or it's not a persistent vector, which means we will deserialize all this data every time, which is also another inconvenience. It's kind of fixed size, but it has an account ID as well. Now, loan requests, not sure what it is, but it's a lookup map, and then a bunch of extra configuration data. Operator is probably the one who rebalances. It's maybe an account ID as well, and treasury is an account ID as well. Cool, so there's a lot of data in the main structure, which will cost extra gas for deserializing it, but the data is not that large, so it's a bunch of integers, which in binary serialization, deserialization are fairly cheap. So it shouldn't be a big issue. Okay, so we're going into new. Contract implements several trades: deposit trade, staking pool, meta staking, and multi-token. Cool. We actually don't have a standard for multi-token yet. We only did one contract token for fungible token. But I guess some contracts might need to support multiple tokens. So they will have to be separate. Okay. All right. So initializing it uses a nice mechanics where you say how much gas you use in a core or in a comment to the method. Ideally, we wouldn't need to do this if there was online simulation, like on RPC level, where you can just tell me how much this transaction gonna take, and it will tell you, so it attaches somewhat the same amount of gas needed. So we initialize a bunch of stuff. And we use return self, but probably a rusty way to just do this. Pink, and it should pink, so deposit, it does internal deposit, withdraw. So one thing we started doing for fungible token standard is security consideration for everything that is payable. So in this case, a withdraw method is payable, or it operates on the amount of positive balances. So in theory, we want to enforce that this is 1 yocta. Maybe we should even introduce a macro right now, something not payable, but require 1 yocta on the API that will actually check the attached deposit is 1 yocta. And eventually we can turn it into contract metadata that will use this decorator to say that this method should not be part of the access key. And the reason for this is like, well, maybe you don't want to withdraw it from access key to your balance or like to some other place. Even so, withdrawal is fairly safe usually. Okay, internal withdraw. Withdraw all. So that would be nice to know how much gas these methods cost, because constructor, you call it only once, so you don't really care. You can attach like ton of gas for the constructor, but for regular methods, it would be interesting to know how much gas it takes.
Yeah, I was imagining also some sort of gas abstraction where, in this case, when there's, some external contract, that external contract could also tell you how much gas it costs. But
So
yeah.
some kind of decorator, you're saying?
Or just like some other like a trait on that contract that would be like that would outline the costs for each method.
Yeah.
So, but that's some fanciness that I've just
Cool.
thought about, but never done anything with.
Chad, hey.
Hey, I see we're looking at something called Metapool.
Yeah, Metapool is like another version of a stake token, but it works with multiple staking pools, and that try to bundle them into one contract and one token that like kind of diversifies across multiple pools. So let's say one pool is like became inactive, you don't really like lose that much value for the next epoch.
Who wrote this?
So this is from Narwhal on a Narwallet from Robert. No, not from Robert. From
Lucio.
Lucio. Yeah.
And how different is it from stake?
I don't know yet. So stake is 1-to-1, so it issues a token for one staking pool. So this is one to many, so it issues one token, but it diversifies across pools that are controlled by operator. So it allows you to, for example, bootstrap low, like pools that have lower fee, but they also like lower on the list. So you don't risk if one of them falls off, but you also like supporting decentralization.
And do I have to pick all my own pools?
No, I think it will be provided by operator. So we don't know yet. I'm still kind of starting to read the API.
Like, seems like maybe something where today operator is an individual, but operator could be turned into a DAO in the future.
Yeah. Yeah, that's how I actually think about access control. So like the contract doesn't have to build into the access control itself. So every contract doesn't need to like have a separate control per owner. Just say one owner to control it. And then this owner is going to be a contract itself that does the governance. Okay, so this is a bunch of stuff like stake, unstake all, getting balances, getting values. So all of this is not as interesting. Get owner ID, reward fee. Etc. uses reward fee, I guess similar to the other contract, the stake and pool contract. Get staking key. Boom. No staking key. Staking passed. Get account. So it looks like it tries to mimic the staking pool API, so it can be considered a staking pool itself. So it kind of like a meta pool, I guess I understand now, is it allows you to kind of deposit here, and then it starts to spread this information, or like this data, this funds into staking pools. Get accounts. Get account info result. What is this? Ooh, it's a large one. So it's kind of like info per account. Okay, cool. Finish on staking. User method completes on stake action by moving from retrieved from pools to available. Try finish on staking pass itself on itself. What? Oh, okay. Journal update account log. So it seems like here we can actually use this debug macro from top. Biased near stake. What? Okay, so it's identical to stake, but it's not payable. So I guess it has to be payable. Oh, you first deposit and then stake, right? Sell, discount basis. So there is some mass that probably you need to check separately. Why are we doing it in U16? Discount basis point. Like, why even cap it into a percentage or something like this? Why not give it like with a larger denominator? All right, so this is one that seems to be interesting. Let's look at the method to sell as near. So this is the amount of stake near you want to sell, and this is how much near you want to get, at least. So you get how many owned, so we convert amount to sell. If it's less than, what is near? Near is one near. Okay. If less than 1 year, we sell in everything. If more than, then we sell the amount. Well, like at least 1 year, then we sell the amount. I don't know what is NSLP. Account. I guess it's some kind of account to keep track of liquidity. Near stake liquidity pool or something. Near to receive, so we look at the liquidity. We call how much you will get if you try to sell to sell. So this is where we found overflow in Vlad's code in the past. So let's see if there's some potential to see an overflow here. Discount basis points is probably like a liquidity fee that you take. apply percent of discount to the amount to sell. That is using U. Okay, so it uses denominator. Okay. Okay, so this is how discount works. So discount works based on liquidity that is available. When you're trying to sell something. So you get less if you're trying to sell all amount because you don't have unstaked balances. So this is how it works. So let's say you have a Uniswap that allows you to convert staked balance to unstaked balance at the current rate of the staked balance. But then someone keeps this unstaked balance unstaked in the liquidity pool, and they earn tokens, or they earn commission for people who needs to skip waiting period. So they don't want like wait 2 days, so like 4 epochs for unstaking to happen. So they just go to the pool and do instant swap. And for doing this, you kind of earn in your more of unstaked balancing, or like more of the staked tokens into the liquidity pool. Then you provide the unstaking, wait for epochs, and rebalance the liquidity pool. So this gives you ability to make profit on unstaked near. And that's the whole goal of this thing. This one returns U128 as well. So that's this into it doesn't. We don't really need this into. Okay, so this is how much near you receive, and if you get less, then we panic. If your available balance is like less, then we also panic, but that shouldn't happen because we calculated it straight from available, so it's unlikely this may happen. It's more like a safety check. Now, how many shares you have to sell? What is share there? Share to amount is proportional total shares rounded down. If you don't have so many, then we panic. So we're saying the liquidity pool decreases the amount of near you get near. What? Why do we need this kind of check? So this check actually verifies that you received less than the amount you sold, but you sold ST near. So in theory, ST near can never go lower, but this is not true because let's say we have a staking pool bug or something like this, and one of the like ST near is non-recoverable, it doesn't earn fee. Well, it's theory, it should be fine. Anyway, so this one calculates how much fee you get. Fee in shares, again, rounded down. No, stake shares from amount. Again, yeah, rounded down. Okay, we pull a bunch of internal accounts. What's important here is none of this should be the same. Otherwise, we will fetch the information that is same account, but there are going to be 3 copies of this account. So let's say a treasury is the same as operator. In this case, we will pull 2 accounts from the state, but they will point to 2 different copies. So if you like modify one here, modify one there, one of these operations will not be received. So treasury gets cut from fee and near. Operators get cut. Then developer swap cut basis points. Non-configurable. So it's like hard-coded. Treasury cut, operator cut, and developer cut. Non-null pcat, meta from operation.
What would be the correct way to deal with the fact that treasury account, operator account, and developer's account could potentially all be the same?
You would probably want to like save this account here and then pull it only after for operator account. So you kind of independently operate on treasury first, then on operators, then on developer. Then you need to like update it again. So maybe you like pull this account again, or you do the math first here. So you will do something like this. Then you move it all here. And then you would do, let's check treasury, then where do we save this account? User NLP. Yeah, so you would do this, then operator account will do it here. And then developer account will be here. So you do a bunch of operations all independently. Well, at least it works for this contract. Like it's possible that it cannot work for a general case. In this case, you just may have to go multiple times to like, oh, let's pull this account again. So this assert better be living somewhere here, because you computed all the values here, and then you don't need to do modifications. I think some of this is already in a variable, so you don't need to recompute them. But anyway, so we add stake shares, and again, this math probably can be optimized into a variable that is already computed somewhere here. Or maybe there's different values. Not sure why it has to be in these variables. Probably not to leak meta to seller or something. But we already updated total meta from operation. Okay. Anyway, so we save the user account to save NSLP account. Again, user account can be an operator account potentially, so you need to be careful what you do here. So maybe when you pull user account, you verify that this is not an operator, but then how does operator take the money? Well, like, cannot operator use it? If you want to avoid it, maybe you should save it here before you start modifying these treasury accounts. So you would like save, but then maybe there's some logic that will be broken at the moment, but probably okay. Or you can introduce arc or reference here. So when you get an account, you don't just get it from the state, but you also cache it locally into like some kind of static cache for the duration of the execution. Anyway, so the only problem if the account now can be an operator, developer, or treasury account. So that might trigger some issue because of this operation and that operation. Not sure if you can just move them here so you don't have to deal with this. So can you potentially like move this logic here? Then maybe you will avoid it because you just move this operation. Not sure why developer takes half of the meta hard-coded here instead of a fee. So maybe it's a logic. Now, next method looks like adding liquidity. So this should be interesting as well. So you say how much you want to add. Assert min amount. What is min amount? 5 near. Ooh. So you can only add at least 5 near.
Do you know why that would be true?
Well, I guess you want to avoid some rounding errors or like some other stuff. So the staking pools, they deal with this issue by having this kind of magical Yocta near fund that is like throwing extra Yocta for rounding. This one doesn't really have this. So LP meter. Stake. Delta staked. And now shares, so total pool value is available balance plus from stake shares plus unstaked, and shares from amount rounded down. So all this rounding down occasionally causes issues. Oh, I guess it's a denominator. Right. Amount, total shares, total amount. So total amount is denominator, total shares is a multiplier. So you multiply amount by shares, divide the total pool value. And that's how you know how many shares you get. So rounding down is fine. So we decrease the balance, we increase the shares, we increase the amount, we increase the shares. So we minted new liquidity, save account. So that works. Remove liquidity should work somewhat similarly. Realize meta. Okay. So let's see what is realized meta. So values in shares, pending meta, realize some give account meta. Cool. So it's a little confusing because there's a meta, there's a stake in shares, and there's like unstaked balances. Not sure if you need both meta and stake in shares, but probably you might need this. I feel like meta is a stake in share, or like shares that we're dealing with. So. Okay. How much we need to remove liquidity? Valued shares, amount from shares. Amount from shares. Proportional. So that's interesting because they do not round up the amount. So like you want to round shares up because you essentially underpaying some rounding error because you remove less shares. Then the amount. Also, I don't know if less than 1 year, then remove all makes sense. I would probably panic saying this. So it kind of like removes unexpected amount. So you say, hey, I want to remove half of the balance or like half of near, but instead it removed full 0.75. So it kind of broke the request. So it removed more. So instead I would say, well, you actually need to remove exactly this amount because it's less than 1 year, instead of letting the user like silently modify the amount of the contract. Okay, stake shares to remove. Remove. Yeah, it looks like liquidity removal is kind of a little more complicated because you need to remove from multiple pieces. I also think there's might be some rounding errors from all this like amount from shares, and like staking pool actually dealt with them by throwing this octaneer extra from the like trillion pool, trillion of octaneers. But this one implementation doesn't do this, so I'm not quite sure how all of this works, but maybe it works from because we have near to actually like unstaked near to actually take it. So yeah, we basically compute rounding error comes from near to remove. All right, cool. So you get near to remove to your account, you get shares and you get unstaked, and we remove your liquidity shares. Now you do reverse from here, you remove all the stuff that you do. Okay, so now it actually makes sense for me. So you have your account that has two values ignoring the meta token. So you have three values. You have available, unstaked, and staked, and liquidity shares. So 4 values. Well, also 50 is a meta. And then on liquidity pool is an account that accounts for all the liquidity for swapping. It tracks the same values. It would probably make sense to somehow wrap them all together if it's possible into maybe a data structure. So you would introduce a method, something like add or remove, that operates on all 4 or 5 values. And this way you don't need to write this separately. So, because you kind of have to do this most of the time. Not sure why liquidity when you provide the liquidity, you don't need to stake. I guess it stakes from your liquid near, but in theory, you should be able to provide liquidity from your already staked balance. Harvest meta. Stake realized meta. What is this? Pending meta, you realized meta? I don't know. I still don't understand meta. Harvest meta from liquid pool. Okay, cool. So that's it. So this is the main method. I haven't actually fully understood the meta logic. We're not going to look at the reward loans or reward internals. Utils, we kind of looked. Types. Hash. So there's some information that you may get. Reward meter, compute rewards, delta. Yeah, not sure if I fully understand why we need both of them in the same contract. So but mostly I understand except for meta. In theory, how would you deal this? You already have staking shares, so why not just operate on these values instead of having this? Okay, maybe there's some distribute staking. Oof. So yeah, that's kind of gonna be expensive. So if this is 75 and then this is 100 plus, oh, not 100 but base, so total 100 plus 20, so 120 for a single staking pool. But where does it call it? It call it SP. Okay, so this is on I guess you need to call it multiple times to iterate on it, so it will do this. Cool. And then there are some callbacks on this, which are gonna verify if we succeeded or not. And same for unstaking. And then query current stake. Yeah, it probably needs extra time to look into this in more details to make sure there's no like API issues or anything like this. And this is kind of obfuscated from the user. So user doesn't have to deal with this, and the operator essentially deals with this kind of stuff. So operator is the pool owner. So let's say this is standalone pool that like spreads this info. And then operator just have to like occasionally ping this. Some gas. Delegators, internal. So this are conversions. Internal and stake, external stake. Internal withdraw. So this is similar to staking pool to be able to act like a regular staking pool. What is this? Get staking pool required stake. It's not public. I knew this is not public. Okay, multi-fungible token. We are not gonna look there. Owner is a pool owner. I'm not sure why I need to add access key. That's coming from lockup, so it's probably just for debugging. Yeah, there are a lot of stuff. How big is the contract? So it's like half a meg of the contract, just because it's a lot of the methods that needs to be handled. And a lot of JSON and Borscht. Cool. I think we can stop today, but it kind of definitely interesting. It's just not very clear from README or the comments how the meta token is used and like what is a meta token. So it would be good to come back and actually figure out how you can use meta token and where you can use it. So I'll stop sharing and we can quickly discuss if there's any particular questions or comments on this contract. No? Okay, cool. Thanks for watching. See you next time.
Thanks, Eugene.